Oh, g'day, Mr. Bennett here. Welcome to Chapter 4. Now, obviously, just a quick review of Chapter 3. Now, the main key concept you're supposed to learn in Chapter 3, as boring as it may have been, was to actually learn how to differentiate a range of functions. So, from a really basic polynomial type function through to ones where you've got implicit differentiation and using the product rule, quotient rule. All right, so I'm assuming now at this stage that you're reasonably okay at differentiating. Now, if you're not very good at it, that's something that you need to practice and something you can get good at. Now, you can either go back through the videos or you can go to Math Online. I know there's some good videos on there, or you could go to Khan Academy. Or you could just do a search on YouTube if you wanted to. So there's a range of resources that you could have access that will help you. You could ask a classmate to help you. You could also come and get some support from me. Alright, so there's a range of ways that you can learn how to do this. It's really about effort, I think, more than ability, because to be in this class that you certainly have the ability. It's really up to you now to take that step. Take ownership of your own learning. Now, when we come to Chapter 4, now we're going to be looking at 4 main types of problems in Chapter 4. Now, they are all related to the same curve, all right? So we're just looking at different ways of looking at one equation, all right? So we'll be doing some questions where we've got rates of change, growth and decay type functions, which we've seen before, but now we're going to be using calculus to answer them. There'll be questions where we're looking at motion in straight lines. So we're looking at 1D, so in other words, an object's going up or down, left or right. And so we'll be talking about terms like displacement, velocity, acceleration, and relating that to the derivatives, all right? And then we'll be doing some graphing questions, okay? We'll be looking at the stationary points, so they're your turning points. I'll be looking at your non-stationary points, points where you change concavity, all right? So, and like most times when I'm talking about the end of the year, you're going to get one of these questions in your exam. Right, there'll be definitely in your test, there'll be definitely a question of each of these type in your test, all right? And then the last type of questions, we're going to be doing some optimization. We'll be maximising and minimising objects, all right? So we'll go through a number of examples for that. So I'll just start off today's video looking at exercise 4A, okay, and we're going to be looking at exercise, looking at rates of change. So I thought we might start by looking at example number 2. Right, the height of a Pinus radiata grown ideal conditions is given by that equation, okay, in metres where t is equal to the number of years after the tree was planted from an established juvenile tree. How high is a tree at planting? Well, obviously when it's planted, t is equal to 0, so that's what we have to work through. Now, these questions, it's a matter of working through each section. And the key thing, I suppose, which relates to calculus is if you are looking at calculus or rate of change, then you have to do the derivative. All right, so how high is it at the tree? That's when t is equal to 0. You might write this, you might write h of 0. That's equal to 20. Take 9 all over 0 plus 5. So that's going to be 20 take 9 over 5. Well, 20 is really equal to, let's do algebra way, 100 take 9 all over 5. So that's equal to 91 over 5. Alright, or you could just work it out as a decimal. Not really fussed, okay? Alright, the other way you could do that is to go to your calculator, by the way. You could go into there, you could graph that, put that function to your calculator, graph it, and then you can find out the value when x is equal to, we're doing number 1, when x is equal to 0, that tells you it's 18.2. Okay, so there's a range of ways of doing it. Now, I'm suggesting when we're doing calculus, when we're doing these sort of functions, really important that you graph these functions so you know what's going on. You can check what you're doing there. Alright, so that's the first big hint I'll give you. Part B, find the height of the tree after 4 years, after 8 years, after 12 years. Well, again, it's just a matter of going h of 4 equals 20, take 9 over 4 plus 5. Well, that's going to be 19 metres, okay? Don't get any marks for your working out here. You only get marks for your answers, okay? So the idea is to do this as quickly as you can. Right, I'm not even going to give you marks for doing this bit here, okay? I'm only give you a mark for getting the right answer there, okay? So that's over plus 5. So you could even just go to your calculator. You could just go over here and go to calc, go to number 1, go 8, and that's 19.3. So that's 19.3, and then you can go to 12, do the same thing over here. Put in 12. Oh, it doesn't work. The reason why it doesn't work is I haven't gone far enough on my scale here, so I increase that to maybe 15. Okay, graph that. Notice there's a function up the top over here. Okay, it's a rational function, so we'd expect to see that, but we're only interested in this part of the curve where t is equal to positive, so that's okay. So count, go to number 1, value, go 12, enter, that's 19.47. So, and you can just write this h of 12 equals 19.47 metres. Okay, and underline it. So the idea is that should be quick. Use your calculator if you can, it just saves time. Alright, next part there says find the rate at which the tree is growing at t equals 0, 5 and 10. Now the rate, when you start talking about rates, so we have to actually differentiate that. So if we're thinking about the 20 term goes out, then we probably need to rewrite that if we're thinking about the h of t being equal to 20, take 9t plus 5 to the minus 1. So when we differentiate that, we're going to get 9t plus 5 minus 2. Then we differentiate inside, and that's 1. We differentiate in respect to t. So that's going to give us an answer of 9 over t plus 5 squared. Okay, so in this particular case, if we're looking at finding the rate when 0, we'll put 0 in there, that will be 9 over 25. If we put in 5, and that's going to be 9 over 10 squared was 100. And if we do h dashed of 10, and that's going to be 9 over 225. Alright, so you get the idea about what we're doing there in relation to finding derivatives. So you find the rate of change first, and then you've got to put the value into there. Now, the next question on this exercise is show that dh dt is greater than 0 for all of t. Alright, so if we go back to our differentiation here, and I've not given myself space, I'll just do it here. Alright, in this particular case, no matter what t, we know that t has to be greater than or equal to 0. So therefore, that implies that t plus 5 all squared is actually greater than 0 for all t, isn't it? Okay, and because it's over 9, so therefore h of t, h dashed of t, has to be greater than or equal to 0 for t greater than 0. Okay, greater than or equal to 0, because t could be equal to 0, but it has to be a positive answer. So that's what it's asking you to talk about there in relation to those exercises. So can I get you to have a go at exercise 4a, and that's simply just doing what we just sort of went through with this example. So good luck with those.